Over the next couple lessons, we're going to discuss the physics and characteristics of sound and why that's important for us to understand so we can appropriately manipulate and monitor our audio. Before we get into things like amplitude and frequency, let's first talk about what sound really is. So sound is basically defined as vibrations through some sort of elastic medium like air that are then perceived by people or animals or just ears in general. So what we need to understand is that we need a few things in order for sound to exist. First, we need a sound source. We need something that vibrates or oscillates to create these vibrations. We need that medium like air, or sound travels through water as well. So we need something for the sound to travel through and then something to pick up that sound. So let's go ahead and take a look at an image of a very basic sound wave. So what we're looking at here is a cycle of one sine wave. And what we see is this wave travels up and then it travels down and then back up again. And so what we're looking at here is what's called a compression and a rarefaction. So we start at a zero line of no acoustic pressure. And as our sound source creates these oscillations, we get a push and a pull of our air. And so this change in pressure is what we refer to as amplitude. Amplitude is what we perceive as volume. Larger changes in air pressure, larger changes in amplitude equate to us as louder sounds. There's a couple of different ways that we can measure this amplitude. Like we were discussing earlier, we could have analog in the air acoustic sounds, but we could also have voltages or we could have digital audio. Now, all of these different ways that we can show amplitude are going to be measured in decibels. Now, depending on what medium we're using, the decibel scale can be different. So in real-world acoustic pressure, we have what's called SPL, sound pressure level. These changes in pressure is what we call amplitude. Now, amplitude is going to equate to us as listeners as volume. So larger pressure changes, larger amplitudes means more volume, louder. Now, volume is going to be measured in what we call decibels, which will usually be shortened as dB. Where that can get tricky is that decibels are exponential as they increase. Now, it's also important to note that this decibel scale is relative to human hearing. So it's how we hear things. So the floor, when we're talking about acoustic real-world sound pressure level, or SPL, we are starting our scale at the zero, at the threshold of human hearing. So 0 dB SPL is the point where humans can't hear anything. As things get louder, we have an exponential gain of how much volume 1 dB actually is. And what I mean by that is the change in perceived volume from 0 dB SPL to 10 dB SPL is, although it's 10 dB, it's going to weigh about the same as a 1 decibel change between 20 and 21 dB. So as we increase the volume, 1 dB matters more and more. Now we have to start thinking about the different mediums in which we can show amplitude. So we talked about dB/SPL, which are real-world acoustic sound level, but what about when we use a microphone and convert it into voltage? So we could use voltage units, or VU, to measure amplitude in a voltage state. Once we convert this to digital audio, we have a new scale to use, dBFS. And this scale works a little bit differently than our SPL scale, Because our SPL is relative to human hearing, we go from 0 and it just goes up till things get as loud as they get. With dBFS, the top of the scale is at 0. And the reason for this is because in the digital world, we have a limitation to how high amplitude can go. And so that's at 0 dBFS, and then it goes down from there. Now that we understand what dB is, let's talk about some safe listening levels. Here we have a scale that kind of gives you an idea of how loud things are. So you have a relative understanding of how loud a car is or how loud a plane is. But what we really want to worry about is how loud we're listening to things. We want to understand the limitations of our ears and at what point our volume gets so loud that it will damage our ears. Generally, a safe and sustained listening volume is going to be around 85 dB SPL. When listening to 85 dB SPL, we can listen to this for up to around 4 hours without any short-term or long-term hearing damage. Once we take a 15-minute break with no loud 85 dB SPL, we can go back to listening for another 4 hours and we can continue this process over and over. So it's important to give your ears a break and some rest as you're working. Once we start to get above that level, when we get to 95 and 100 dB SPL, that becomes exponentially more damaging. So when we're listening at 105 dB SPL, that's gonna drop down to about 10 minutes before we can suffer any type of hearing damage. And then we'll need an increased period of rest from this. So try to get a good idea of how loud things are. You can get a SPL metering app on your phone and just understand how loud things are and try to remove yourself from loud situations, or even if you go to a concert, just take a break to keep your ears safe. Now that we understand amplitude and volume and some safe ways to listen to things, let's take a look at what frequency is.